Today, we're diving into one of the biggest philosophical questions out there, one that's hiding in plain sight. It's a mystery that connects everything from your phone to the most distant stars. We're talking, of course, about mathematics.
So let's get right to it. Is math just a tool we humans invented, kind of like a hammer, to help us build and understand our world? Or is it something else, something that was already out there, a kind of cosmic blueprint that we're just slowly but surely uncovering? This one question, it really splits the whole field right down the middle.
To even begin to get to the bottom of this, we've got to understand that not all math is created for the same reason. You could say there are really two different worlds that mathematicians live in.
And this divide is pretty fundamental. On one side, you've got applied mathematics. This is probably the stuff you're most familiar with, using things like statistics or game theory to model and solve actual problems in the real world. But on the other side, you have pure mathematics, and that's where concepts are explored just for their own abstract beauty, totally disconnected from any practical use. Or so it seems at first. So let's just wind the clock back for a second. For most of human history, this split between pure and applied math, it didn't really exist. Math was born from some very, very practical needs.
For thousands of years, this was pretty much it. Math was about counting your stuff and measuring your space. You had numbers and you had shapes. That was the whole game, and all of it was tied directly to the physical world. You can see this slow, steady progression of ideas. It all starts with really practical stuff in ancient Egypt, building and taxes. Then, the Greeks come along and give us a massive upgrade, the idea of a logical proof. That was a total game changer. Centuries later, Al-Khwarizmi gives us algebra, and then Newton and Leibniz invent calculus to describe how things change. And boom, those became the four classical pillars of mathematics.
So for a long, long time, those four pillars, arithmetic, geometry, algebra, and calculus, were the foundation for everything. But then, right at the end of the 19th century, something happened that caused the whole field of mathematics to just explode.
It was wild. All of a sudden, mathematicians started finding cracks in the very foundations of their field. Simple ideas like, what is a set, were leading to these mind-bending paradoxes. It was a real crisis. To fix it, they had to rebuild everything from the ground up, based not on what felt right, but on pure, rock-solid logic, starting from a few basic truths or axioms.
And this massive rebuilding project, it had a pretty staggering consequence. It took math from just a handful of fields to this number, 63. So what does that even mean?
Well, that number, 63, represents the major branches of mathematics that are recognized today. Just think about that for a second. We went from those four ancient pillars to this huge, sprawling city of interconnected ideas. The whole field branched out in ways that nobody could have seen coming.
And here's just a little peek at some of those new neighborhoods in the city of math. You've got things like group theory, which is the study of symmetry, or topology, which studies shapes you can stretch and bend. And a lot of these started out as just abstract, purely mental exercises.
And this is where we get to the heart of the mystery. What happens when these purely abstract, seemingly useless ideas turn out to be, well, unbelievably useful?
The physicist Eugene Wigner just nailed it with this phrase. Why on earth should math, especially the pure math that was developed just for the fun of it, be so ridiculously good at describing how the universe actually works? It's a phenomenon that really makes you think that maybe math is being discovered, not invented.
Let's look at a perfect example, prime numbers. For more than 2,000 years, they were basically just a fun puzzle for mathematicians. People studied them for the pure joy of it. Honestly, they were the very definition of unuseless knowledge.
Until, now. Today, the entire security of the internet, every single secure transaction you make, is built on the properties of those exact same useless prime numbers. It's an application the ancient Greeks could have never, ever imagined. Okay, here's another one for you. The ancient Greeks were fascinated with the shapes you could make by slicing a cone in different ways. And one of those shapes was the ellipse. To them, it was just this beautiful, abstract curve, nothing more.
Now fast forward almost 2,000 years. A guy named Johannes Kepler is trying to figure out how the planets move. And the answer? It turns out they move in ellipses. That abstract shape from an ancient Greek thought experiment was the hidden blueprint for our entire solar system. All right, let's jump to a more modern case. Back in the 19th century, some mathematicians started to play around with the basic rules of geometry. They asked, what if parallel lines could meet? It created these bizarre, warped geometries that seemed completely disconnected from the world we actually live in.
And then who shows up? Albert Einstein. He needed a language to describe his radical new idea of gravity as a curve in the fabric of space-time itself. And where did he find it? In that weird, unrealistic, non-Euclidean geometry. The abstract thought experiment became the literal language of the cosmos.
So, the evidence for math being discovered seems pretty overwhelming, right? But hold on. If math is just out there, waiting for us to find it, where does the human element fit in? If we ignore the sheer creativity and artistry involved, we're really missing half the story.
See, the engine that drives all of mathematics is the proof. A proof is what separates math from science. It isn't about experiments, it's about pure, deductive logic that leads to absolute certainty. And building an elegant proof, well, that's an act of pure creativity.
And this is where the invention argument comes roaring back. A lot of mathematicians will tell you they see their work as a kind of creative art. They aren't just uncovering facts, they're building these beautiful, elegant structures out of logic, and they're guided by a sense of aesthetic beauty.
And this way of thinking, it's woven right into the fabric of our culture. It's in the simple ratios that make music sound so good. It's in the symmetry we find beautiful in art and design. It's even in that little spark of joy you get when you finally crack a tough puzzle. These aren't cosmic laws we're discovering, they're patterns we're creating and admiring. So, invented or discovered? Maybe the answer is both. Maybe math is a language we invented to describe a universe that is, for some deep and mysterious reason, profoundly mathematical. And that leaves us with the biggest question of all. What other secrets are out there, waiting for us to find the right words to describe them? What new worlds will this language help us find next?